In part 14, I got a response from a fellow named P.S. Kittle 488, and he wanted to know if I would ever strip down the chassis completely to restore it, or would I consider it just too much of a hassle to do. Well, I have done it, and here it is. It was an Atwater Kent 856 from 1936. It was one of the last they made. And as you can see, the radio was a mouse house for many years. Had tons of rust. I had to really grind away on it with, by hand with emery cloth. I used really coarse emery cloth, and after I removed everything, of course. And then I showered down on it with navel jelly for about 3 or 4 days and just let it set for 8-10 hours at a time. Applying one coat after another in between, grinding more of that rust off with the emery cloth. And this is what I had after the rust was removed. I then handed the chassis over to a friend of mine who does chroming, and he put 3 coats of nickel and a top coat of chrome on it. He didn't have the ability to copper plate it first. So he didn't charge me anything, and there's still some micro pitting on there, very micro. But compared to what it was, he did an outstanding job, I thought. And here the radio is all put back together and playing fine. But yes, there are times when you want to strip down a chassis. Now we're getting ready to paint the old chassis. But you know, one of my YouTube followers, video followers, named Mr. Robert 5, had a concern about me painting it silver. Well, he said, why paint it silver? Paint it clear and it'll look spiffy. Now I'm going to go ahead and try, I'm willing to give it a try, spray this baby with some clear coat. I have no problem with that. We're going to go ahead and try it, spray it all down, and see what it looks like when we get done. And as you'll notice, I have an awful lot of dark and missing plating all around this thing. If it doesn't turn out good, or it's just not up to what I want it to be, after the clear coat is on, then we'll come back and I'm going to spray it this time with Rust-Oleum Appliance Epoxy paint. I was told about this several years ago. I was told that this thing really does a good job of matching up the original chassis color. And it's epoxy, so it really works good. So, you know, this is one of these win-win situations for me, because I'll go along with what Mr. Robert 5 wants. We'll give it a shot, sure. And if it works, great. And then I'll say, hey, we all learned something, to include myself and everybody. But if it doesn't work out and it still looks like crap with all the plating missing, and especially on the rear, let me go ahead and pull you around there. There's a lot of it missing back there, you can see, all that dark area. So let's see what happens. I don't know. It's like I anticipated that it would accentuate the missing areas, the areas where the plating is missing, and it has. Now, of course, this right here will be covered up by the tuner. The variable capacitor will cover that up, but you know, it doesn't cover this area here where it's all missing, and it doesn't cover on the back where it's all missing. You can really see it around here where there's mostly gone, but there's still some there. I don't know, you know. So what I did was I went ahead and sprayed this piece of cardboard with the epoxy appliance paint. And this is what I've got, and that's what the chassis would look like. It's a very nice paint, by the way. And so here's what I'm going to do. I'm going to let you guys tell me what to do. Right now I'm leaning back toward the silver paint because of all the missing plating. But, you know, the chassis is protected right now as it stands. I'll probably, if we wind up going with the clear coat, I'll put a second coat on. I'm just going to stop what I'm doing right now as far as paint goes. And you all tell me what you want. You want to go with this? I want you to be very serious about it now. Think about it. That's a very fine, misty paint. It looks real good. Got a pretty nice color as far as matching the original plating goes. Let me see if I can get some plating around here where we can get a better idea. Not too shabby, really. But anyway, what do you think we should do? While we're waiting for the decision to be made about whether to paint or silver or clear coat, we might as well go ahead and start changing out some of these components. And we're going to start with this old burnt 2-watt resistor right here. That's a 4K resistor. And we're also going to change this capacitor, which is a 0.05. We've already gone over that in a previous video. And then it'll be just a matter of going to the schematic and looking at each one of these to make sure they're the right capacitor in the right place, and just changing them out. This 4K resistor, 2-watt, is it was a little bit difficult to find. I couldn't find one. I came close, but no cigar. So what I decided to do was I went out on eBay and I bought a 5-watt 4K ceramic resistor and power resistor type of thing, and I'm going to go ahead and put that in there. It's lots of overkill, but so what? I noticed in a couple of postings on various websites a while back, and on YouTube if I'm not mistaken, a fella was using one of these to remove solder, and a couple of guys, they chimed in and said, what is that blue thing? What is that thing? I was kind of surprised that people didn't know what it was. It is a solder extractor, and it's nothing but a plunger with a spring inside that locks down in place. And then you take your soldering iron, you melt the solder, you soften it up till it's liquid. Then there's a little button on the side here, right here, and then it's got that neoprene tip. I think it's neoprene, so it doesn't melt very easily. You got your soldering iron on one side, you got your solder all soft and liquidy, and then you take that baby and put it up in there, and then you hit the button, and it extracts that solder right off of there. And it just sucks it up inside. Now, of course, eventually you get so much solder in there, you got to take it apart and clean it, which I did before I began this operation today. So that's what the blue thing is, folks, a solder extractor. Some people call it solder sucker. Here I've got the capacitor loose on one end off of this terminal right here, and I have the resistor loose also. You can see how black and messed up that thing is. Now what we're going to do is we're going to take the old alcohol brush and start cleaning up underneath that whole area right there. Incidentally, there was a wire right here that connected to this terminal also, but once I took it and unwound it, it was too short. The insulation was all ratty, so I put an extension on it, just like we did with the transformer. Piece of cake. Here's something you'll run into once in a while. You have a wire that runs from this terminal here. It comes down and it's supposed to wrap around this terminal here. But what they do is run one continuous wire and then just strip a portion of it and then solder it in place and then let the wire continue on where it's going to go. I don't like that. I'm going to cut that wire and put it on there separately so I have a much better connection. So we'll cut it right about in the middle. Now I can go ahead and redress this wire up and away from the components in the center here where I'll be working with. And the other one, of course, will be stripped back a little bit and soldered on also. When you solder your components in, your capacitors, always position the writing so you can read what the value is after the capacitor has been soldered in. There's nothing worse than have the value on the bottom, and when you're maybe troubleshooting later on to find out maybe something is not working quite right, and you come up to this capacitor and you say, geez, I wonder if I put the right value in there, I might have made a mistake. So put your writing where you can read it. It's a sign of professionalism too. It's a sign of a fella or a woman who's working on a radio who takes their time and does, pays attention to detail. They write the value on those capacitors for a reason, so we can read them. Before resoldering the lead for this 4,000 ohm 1-watt resistor here back to where I put the new resistor and capacitor in, I wanted to check the resistance one more time because the paint had been bubbled up. There's a lot of heat went through there and bubbled that paint up. It could be caused by the heat, it could be caused by just age, but a bubble generally means heat. So if we look at it, we're still sitting pretty, very close to 4K, 4,000 ohms. So what I'm going to do is go ahead and solder that back on and just sort of keep an eye on it. You know, when I see a resistor, normally I would replace that, but not this time. I'm going to see what happens. I just changed the heat shrink that was on here that protected this wire. The old stuff was just hard as a rock, and it's just, you can't even hardly bend it. So I went ahead and before I soldered it up, I stuck a new piece on. Well, that's what we're going to be doing. I'll continue to work on this board right here until I get it all done. All of these caps will all be changed, and I'll ohm out each of the resistors. It's just going to be repetition over and over and over. You'll remember that this 20K needs to be replaced, and all of these will go. And then when I'm done with that, we'll come over here and work on the electrolytics. We'll get all those in place, and I'll come back once I get all that done. I'll come back and we'll tear apart this Bakelite block you see down in there, and I'll show you what's in there and how we go about getting it out and what we replace it with. This radio has a second block right here. I once worked on a Philco that had 7 of those blocks. What a pain. But there's one good thing about working on 7 Bakelite blocks in a Philco radio. You learn how to do it. Believe me, I learned how to do it. So, it's time to move on to something else, and then we'll end the video. Okay, let's take out this capacitor that's underneath that paper that I showed you earlier. Now, a lot of people dig around. They'll get a screwdriver out and they'll dig it and dig it and dig it. Not necessary. There's an easier way. Just go ahead and use a heat gun to soften up the outside, and then after it gets softened up, just take a pair of pliers, grab a hold of the paper, and the whole thing should lift right out. Well, let's find out if that philosophy works now. And as you see, she's lifting right up out of there. I'll go ahead and pull it from the other side now, and the whole thing should come right out in one piece. Incidentally, that tar-like substance is actually a waxy tar. It's not real tar. If you don't heat the outside, this stuff will grip the side of that thing, so that's why I had to apply a little heat. The rest of it's covered with this paper. Well, there it is. The paper is removed from the outside, and it's already started coming apart. And as you can see, it's more of a crumbly kind of wax. So what I'm going to do now is I'm going to tear that thing open, get all that wax off there, and show you what's inside. That's what was inside all that stuff. It's just a foil and paper capacitor.